So we're all asking AI to write our emails, our code, even our poetry. But how do we actually know if it's doing a good job? Now you'd think that's a simple question, right? Well, it turns out to be one of the single biggest challenges in the entire field of AI. Today, we're going to break down how you grade an AI because let's face it, if you can't measure it, you can't improve it.
I mean, really think about that for a second. You ask an AI to write a song, and it gives you something amazing. You ask it to debug some code, and boom, it saves you hours. But how do you put a number on that? How do you score creativity or helpfulness? Is it an 8 out of 10? A B+? That's the core problem we're diving into.
All right, so here's our game plan. We'll start with why this is such a hard problem in the first place. Then we'll look at the 3 big solutions people have tried: using human judgment, creating an automated rulebook, and the really wild idea of using one AI to judge another. We'll also dig into the hidden biases that come with that, and we'll wrap up with the standardized tests that have become the final exams for these models.
So here's the fundamental issue. With language, there's almost never a single right answer. If you ask an AI to, say, describe a beautiful sunset, there are literally a million different, wonderful ways to do it. It's not a math problem where the answer is just 42 and you're done. This makes creating any kind of consistent, scalable grading system incredibly tricky.
Okay, so what's the most intuitive solution? Let's just ask people, right? This is widely considered the gold standard because, we humans are pretty good at understanding nuance, subjectivity, and quality. In a perfect world, we just have a person review every single thing an AI generates.
Yeah, but that perfect world runs into some pretty big real-world problems really fast. First off, using human raters is incredibly slow. It's also super expensive. And maybe most importantly, our judgments are deeply subjective. What you think is a brilliant, poetic answer, I might find totally unhelpful.
And this brings up a really important concept in this field: inter-rater agreement. It's basically a score, often measured using a stat called Cohen's kappa, that tells you how often 2 people agree on the same judgment. If your graders can't agree, you can't trust your data. It's as simple as that.
And get this is what really puts it into perspective. If you had 2 people just flip a coin for every answer, good or bad, they would still agree 50% of the time, just by pure random chance. So a 50% agreement rate means your feedback is literally as good as a coin toss. You have to do way better than that for any of this to be useful. Okay, so if humans are slow, expensive, and they disagree all the time, what's next? Well, for a while, researchers turned to automated rulebooks. The idea seemed pretty clever. Have a person write one single perfect reference answer and then use a formula to score the AI based on how close its response is to that reference.
But this whole idea immediately slammed into a wall, and this quote really captures why. Language is just incredibly flexible. There are so many ways to express the exact same idea, and a rigid mathematical formula really struggles to get that. Just look at this example. On the left, you have the perfect answer. On the right, the model's answer. They mean the exact same thing, right? We know that. But an old-school grader, using a metric like blue or rouge, would give this a terrible score. Why? Because it's literally just counting how many words are the same. It's matching keywords, not understanding meaning.
So yeah, these rule-based systems were kind of a dead end. They punish any kind of creativity or stylistic difference. Their scores don't actually line up very well with what humans think is good, and you still need a person to write that perfect reference answer in the first place. We clearly needed a much smarter approach.
Which brings us to the modern solution. And honestly, it's a pretty fascinating one. What if we use a really powerful AI to grade another AI? This idea is called LLM as a judge, and it pretty much changed the whole game.
Okay. So here's how it works. You give the judge AI everything it needs: the original prompt, the answer it has to grade, and your scoring criteria. It analyzes it, but here's the secret sauce. You force the judge to write out its reasoning, its rationale, before it's allowed to give a score. This little chain of thought trick stops it from making lazy judgments and gives you way more reliable evaluations.
And you can see why this was such a huge deal, right? Suddenly, you don't need a pre-written reference answer anymore. You get a clear explanation for every single score. And you can finally start to evaluate those fuzzy, subjective things like usefulness or creativity. It's fast, it's scalable, and it's incredibly powerful.
But you knew there was a but coming, right? Of course, this method isn't perfect either. Even these super smart AI judges have their own weird hidden biases that researchers have had to discover and learn how to work around. First up, there's something called position bias.
It's weird, but if you ask an AI judge to compare answer A and answer B, it has a slight tendency to like answer A more, just because it saw it first. The order you present things in can actually change the outcome.
Next, we've got verbosity bias. Basically, the AI judge has this little flaw where it thinks longer equals better. It tends to give higher scores to more detailed, wordy answers, even if a short, to-the-point answer is actually way more helpful. And this last one is really fascinating: self-enhancement bias. A model will actually tend to prefer answers that were written by itself or by another AI that has a similar style. It's pretty much the AI version of grading your own homework. You're probably going to be a little too nice.
The good news is researchers have figured out ways to deal with all of these. To fix position bias, you just swap the order of the answers and run the test a second time. For verbosity bias, you can add a simple instruction like, do not favor longer answers. And to avoid self-enhancement bias, the best practice is to always use a different and usually more powerful model to be the judge.
All right, so we've got human graders, we've got AI judges, but how do the big companies, the Googles, the OpenAIs, actually compare their giant models against each other on a global scale? Well, that's where the final piece of this puzzle comes in: standardized benchmarks.
The simplest way to think about it is this. Benchmarks are basically the SATs for AI models. They are massive, standardized exams designed to measure a model's abilities across a huge range of specific skills. And man, these tests cover just about everything you can imagine. You've got academic tests like MLLU, which is like a final exam covering 57 different subjects from history to law. Then you've got practical skill tests like SWE Bench, which makes the AI try to fix real bugs from actual open source software projects. And critically, you have safety tests like Harm Bench, which are designed to poke and prod the AI to see if it can be tricked into generating dangerous or harmful content.
And all of this brings us to one final huge question. We started this whole journey with human judgment being our gold standard, right? But now, we've built these AI judges that are faster, cheaper, and often more consistent than we are. So as these AI systems get better and better at grading each other, will we eventually reach a point where their standards of what's good actually matter more than our own? Something to think about. Thanks for joining me.